Alright, welcome. Today we'll be talking about geometry, reasoning in algebra and geometry. Okay, now reasoning in algebra, pretty easy. You guys have actually done this a bunch, you just haven't listed all the reasons. Okay, so for example, 3x minus 5 equals 17. Okay, something that looks like this. Okay, alright, now reasoning, what we're going to do is we're going to structure it so that we can understand it. Okay, and we're going to structure it in this way. It's going to be structured in a proof. So we're going to have the statement over here, and we're going to have the reason over here. Because if we have it set up like this, it's going to make a whole lot more sense. Okay, so this is statement 1. We have our actual problem. Now we'd usually say, oh, that's the problem given. Well, we're just going to call that given. Okay, so the first reason you're ever going to give for any of your reasonings is you're just going to say given. Okay, step number 2, I'm going to add 5 to both sides, and I get 3x equals 22. Okay. Alright, now the reason is, well, we said we added 5 to both sides, but why? Why can you add 5 to both sides? And we're going to call that the addition, which it is called property of equality. I like to call it addition po. Okay. Alright, and then step number 3, we're going to divide both sides by 3, and we get x equals 22 over 3rd. Okay, and so we finished off and we go, oh, we're done. No, we still need a reason. Okay, now the reason why we could do it is the same as the one before. It's going to be division, but it's going to be it's going to be a property of equality, but it's division. If you divide one side, you can divide the other by the same thing. Okay. And then we would finish off our nice little proof in geometry with this QED, that which has been proven. Has been. Okay, and I'm paraphrasing Greek very badly in that. For the last 10 years, I thought that was Latin. Okay, but this is how reasoning in geometry and algebra work. You state your reasons, or you state your statements, and then you give your reasons of why you could do that. Except now we have very specific names for it. Okay, now if you really want an in-depth look at how we do a proof, please understand there's going to be there's going to be 3 different types. There's going to be paragraph proof. Okay, where it's going to be statement, then reason, period, next statement, then reason, and then so on until you get to the actual answer. Okay, so it just works that way. Paragraphs, they're not as elegant. This right here is an example of a 2-column proof. Okay, it's just a lovely thing that just works out for everyone. So 2-column proof just is amazing in how it's set up. It has statements on the left, reasons on the right, and here's an interesting thing: your first step is always a given. Okay, the other steps are totally up to you how you want to use them. Okay, now what do we use here for our reasons? Okay, reasons, you use postulates, axioms, theorems, rules, definitions, and so on and so on. As long as they're mathematical facts. That have been proven. If you can do that, if you can use those and you've had it proven, you can use it, basically. But you're just going to list your statements over here and just be able to work over there. So let's get some examples of geometric proofs. Okay. Let's go simple proof. I don't want to start. Proof example. Okay, just loading it apparently takes a long time. Okay. So what you want to do is you want to have your picture drawn out of whatever it is you're working with. This is how we do proofs. Okay. Angle 1, angle 2. Okay, and then you want to list out your reasons or your givens. Okay, so given angles 1 and 2 are complementary. Okay, and the measurement of angle 2 is equal to 74 degrees. Okay, and we want to prove, and you are going to be given your proof. Measure of angle 1 is equal to 16. Okay. Alright, so this is what we want to, this is what we start with, and this is what we want to prove. Okay. Alright, so we start a 2-column proof, we write it right here. Let me bookmark this bad boy. There we go. No, back to here. Okay, so we have our statements over on the left-hand side. So statements. We have our reasons over here. Okay, so statement 1, and what you want to do is you just want to list all of your givens in the beginning. Okay, so I'm just going to copy. Let's go like this, boom. Okay, so we just want to list that. And so we're just going to list that reason out as given. That's always your first statement. Okay, now we want to draw over here what that means. Okay, so this is 74. Okay, we don't know what this is. That's what we're looking for. Okay, we know it's going to be 16, but we want to prove it and stuff. Okay, so we know angles 1 and 2 are complementary. So what we're going to do is go, what is the definition of complementary? That means angle 1 plus angle 2 is equal to 90 degrees. It has to be. Okay, and why is that? Well, that's because of the definition of complementary. Okay. Alright, and I already know measurement of angle 2 is 74, so I can replace that with angle 1 plus 74 degrees has to be 90. Okay, and we call that, now we don't call that replacement, we call that substitution. So we substitution. Okay, so we just substituted the value of 74 in for angle 2. Okay, now what we're going to do is we are going to subtract 74 to both sides, and we get angle 1 is equal to 16 degrees because I checked on my calculator. Okay, now if you notice that's the last step, and I'm like, oh man, I'm done. I don't need. You do need to say your last reason, and your reason was you subtracted from both sides, so we have to call that the subtraction property of equality, or subtraction PO. Okay, and then once you get to the last step, you can finally say your big Greek statement QED, and you're done. And so that's how a proof works. Okay, all right, you guys. Thank you very much. There's a whole bunch of different ways you guys can actually do proofs. Just realize you just have to back up each statement as you go, and sometimes you might have to actually say some stuff. It's a little bit interesting, but you know, pretty easy stuff to work with. Okay. All right. Thank you guys very much, and have a great day. Bye.